Hey, my name's Stuck, and if you're looking for a tutorial where you've started with TypeScript and you want to get into Godot, or even if you started with JavaScript, this is a tutorial for you. So go ahead and stick around and learn some things. In Godot, you have individual scripts that can be attached to individual nodes. What I mean by that is I have this icon here, which is now in the 2D space, and I can right click on this. I can do attach script. I'm going to call this my icon. Okay, it's essentially like creating a new file. Now that I have this script, I can do things to this specific icon, but only this specific icon and essentially most of the stuff that's under it. And what I'm going to do first is just kind of show you, I'm going to move this across the screen, right? So we're going to go ahead and do process, and we're going to do position, we're going to do self position x plus equals 0.1. So what we'll see is when I run this script, you're going to see this moving to the right just ever so slightly. Okay, so there we go. We have our first script. It's attached to something and it's making something do something, right? Pretty simple stuff. All right, now that we have our script attached, what we're going to actually do is look into variables, because that's a pretty big topic. Every single programming language has their own iteration of what a variable is. So in the case of Godot Script, the way that we write variables is we use var. So we're going back in time if you're a JavaScript developer, and we can actually assign different types to them in a pretty simple way. So let's just call this my variable. We're going to assign it the integer type, and we can assign it 5, right? Pretty simple, okay? So let's add some other things. We could do a string like this. We can do a float, which looks like this. We can do, let's go ahead and actually rename these a little bit. Except I can't count. There we go. Yeah, so we want to actually kind of rename these a little bit. But generally speaking, these variables specifically, they all can have different types assigned to them, kind of similar to TypeScript. Like this almost looks exactly like TypeScript, right? Pretty easy to see, pretty easy to kind of understand. I have a colon, I can put a type against it, and it can be that type. We don't get the benefit of things like union types, so this is not valid to do something like this. So you actually do need to strictly have one type per variable where possible. Now, there are additional ways around that. Like in TypeScript or JavaScript, we have an object and we don't have an object. So what we can do instead is use a class. And to create an internal class that is only accessible inside of this specific script, we just do class, we'll just call it something, and that's pretty much it. We're going to need to add a colon after there, and then we can actually define some of the stuff that's inside of the class. So for example, we could do maybe health, an integer, or maybe armor, also an integer, and so on and so forth. And the way that this would actually work is that if I needed the something class, I could do my test something. I can define the something as like an interface. So think of this like, if you're coming from TypeScript, think of this like the interface that you see. And then what I can do is then specifically just assign a new version of it, and then I can assign some additional data to it as well. So my test something that health, set that to 100, and so on and so forth. In the case here, we actually can't write code on the top level. Variables and stuff can. So what we actually need to do is just actually wrap this in a function. There is a ready function that is available in every single script that you start with. It is highly recommended to actually put that in there. But that being said, you can directly assign the values pretty much by doing this. And you have your class instance essentially, and you can pass this interface to other objects and so on and so forth. So hopefully that makes a little bit sense about the variables. So you do also have things like arrays, and you also have things like vectors as well. which are all, or not vectors, but dictionaries is what I mean. You don't get any special type, useful type for dictionary. It kind of just works like a regular JavaScript object, which is, you know, it is what it is. So you would be able to do something like this, and that's still going to be something that you can print out. So if I was to get my var for test, functions just like TypeScript or JavaScript objects for dictionaries. I mean, hey, just use a dictionary instead for your interface or whatever. You just don't get that nice auto-completion that this would give you. But that being said, if I was to run the script real quick, you can see hi down here, which is from being assigned inside of this dictionary. But that being said, so the way to actually do arrays is actually like this. You do array, put it in some brackets, and you throw something in like string or whatever. And then you can actually just use it normally like that. And, you know, down here, print my var5. Get the first element, we'll go ahead and print that. Print it to console here. There we go. Okay. That kind of covers variables, I would say. Alright, so now we're going to go ahead and talk about functions. I've gone ahead and wiped out this whole document here. So functions, generally speaking, you're already looking at one. This is the first function that is called when the script is started. So I can just print script started, or run the script. There we go, script started, right? Now what we're going to do is write a function ourselves. Let's just call this function test. We're going to move print up to here, and then we're going to call the function normally just like a JavaScript or TypeScript function, right? Go ahead and print play. There we go, script started. Okay, so here's the next piece of this. If you want to use variables, get ready for essentially more TypeScript. You're going to do test string, and then we're going to just print test, and I can pass hello world through it, and that's going to print that for me. Hello world, right? Pretty simple, just like TypeScript, very easy. Now let's say we wanted to do the traditional add function, where we add two numbers together and then just return a number. So let me show you what that's going to look like. So we'll do num1, num2, and we're going to do return num1 plus num2. All right, so you can return this, like you can return stuff normally, right? We can get a result like this. But if we want to explicitly state what is being returned, we use like this skinny arrow function here, and we specify what is meant to be returned, which is an integer. So this is the return value here, and then here we are passing two values. So we're adding two, and then we're getting a result as essentially an integer, just like that. And if I print the result, we will definitely see 10 in console. All right, very simple stuff. Now, another thing to keep in mind is that if you are doing something like math equations, where you need to do math.ceiling or math.floor, so on and so forth, math.x, you know what I mean? Instead, you need to do like print floor results or print ceiling results. So you see what I'm getting at here? You don't actually append math.x or math.y. You just call them directly. So if I actually just replay the script here, you'll see the two different values there for a ceiling and a floor. Now, let's say that we go into if statements here, because we already figured out how to do these functions. Let's talk about if statements. So if statements are pretty much, we don't have these fancy curly brackets, so that means we're kind of writing our functions similarly to how Python is. So what we do is we do if result is greater or is less than or equal to 10. What we are going to do is print result was less than or equal to 10, and else greater than 10. Okay, very simple. Little comparison there. If I run this, we get our result down here. It's greater than 10. So if statements are very simple. You don't always have to have an else. You can also chain them together like this, which is great. This is probably my favorite way to write code, especially with a lot of if statements. So if we run it like that, it'll still go through each individual if statement, but we'll also get the result that is relevant to the situation here. Now, let's go ahead and talk about switch. So the switch statement does not exist under the same name that we all know it. It's actually called match. So if we do my value 1, we do match my value, there is no case, right? We don't do case. Instead, we're looking for the exact value. So if it's actually equal to 1, we can do print this is 1. Or if it's equal to 2, we can do print this is 2. And if we want a default, you do an underscore and say print this was default. Okay, so if we go ahead and run this, see what some of these results look like. We have this is 1 because it found 1, obviously. But if I make this something like 7, refresh that, this was default. Okay, so match statements pretty much similar to switch, just a little bit different syntax. Okay, so now we're going to go ahead and talk about classes. Now, classes actually exist in 2 different forms inside of Godot. We actually covered one of the versions earlier on in the video, what is called an internal class. That makes it so that this class is only available specifically inside of this script, right? And in most cases, that's not really useful for a lot of people. Generally speaking, we'll actually only be using it for maybe just organizing some data. But you can do my class.new, kind of like this, and then you could access the individual properties and assign values to them based on what you're doing with that. But that being said, classes are generally pretty great for internal usage and organizing more complicated structures, but in most cases you're going to want to use them externally. And to use them externally, what we need to do is actually create a new script. So if I go to File, New Script, let's call it my class, and we're going to go ahead and make it. So the way that it works is you would do class underscore name, and we'll call it my global class. And then what we can do is actually directly add the data just like we did in the other one, just like this, and assign those values. And then what I can do is access this anywhere from any script. So I can go into ready here, and I can get rid of this one up here and do, let's see, my global class. So if I go data my global class, I can call new, and then I can assign that data directly just like I did before. Now, what's really great is we still have constructors. So constructors exist in a different form. Normally in JavaScript you do something like this, or TypeScript. Here we're actually doing init, like this, and I can pass the individual starting data through here. So I could do like starter health is an integer, and starter armor is also an integer, and then I can assign those directly by doing self health equals starter health, and then self armor equals starter armor. If I go back to the the class over here, what I'll see is it's expecting 2 arguments, and we've currently received 0, so I can pass 150, and that'll still function all the same. Print data health. Right, pretty simple stuff. Now the next thing that I wanted to talk about actually was singletons. Now singletons are really useful because it stores state kind of like a static way where it's just globally accessible anywhere. This is something that does exist inside of JavaScript and TypeScript. Usually you will actually make a function that gets these different pieces of data and returns them, but I'm going to show you how to do it inside of Godot in a somewhat similar way. So let's say that I wanted to get a starting value for health, and I'm just storing it globally or something of the sort. So what I can do is create a new script. I can call it something like my globals. And inside of here, what I can do is just do a property that's going to be exported. So I can do like variable starting health. We'll give it an integer and we'll give it 100. Variable starting armor integer 100. And then maybe what I want to do is make a function that take 5 health. Just removes 5 health. We'll do starting health minus equals 5. Okay. In order to make global data available with only one instance of it existing, we go to project settings, and we go to auto load. This means that the script that you assign is going to be automatically loaded into the game, and it's going to be like one of the first scripts that gets loaded. So if I go over here, I click add and go to my globals, I'm going to call it, well, my globals. That seems like a pretty good name for it. Once it's added in here, after hitting add, I can close this, save. I can go into my icon, and what I can do is now get that information. So I can do print my globals dot health, starting health, like that. And then what I can do is maybe I want to subtract it or whatever. I do my globals dot remove. Oh, what was it? Subtract 5 health or something. Subtract. I can't remember the name of it. Hold on. Take 5 health. Take 5 health, just like that. Call the function. And then what I can do is print that same global here, like that. We'll see a difference in the results by refreshing. There you go. 100 to 95. And that's how you use singletons. So you can actually have quite a few of these auto loads. Are really useful for things like audio instancing and loading more just global state and storing that global state and so on and so forth. So yeah, that covers classes for Godot, I would say. All right, we're gonna go in 3, 2, 1. Okay, so the next thing that we're actually going to talk about is signals. And a signal is essentially like a callback in its own way. It's actually kind of like an event system where you pass a message or data through a function, and you can get it either as a parent or a child or so on and so forth. What I will show you is how to actually call a function directly from parent to child, but also how to pass data up to a parent through a method which is basically called bubbling up. Now, let's go ahead and start by adding a new script on top of Node2D. Like this, we're just going to call it example. And we're going to go ahead and use the ready function. And that's all we're going to do. Inside of the icon script, we're going to add a few things. One of them is a new function we will call invoke from parent. And it's just going to be print. It's going to print this was invoked by the parent. Okay. We're going to copy the name of this. We're going to head back over to the other script. Now, in the script that's here in Node2D, so we're above the icon script. Okay, so we're in the parent of the icon script. We're going to go ahead and make a single. We're going to go ahead and set up a variable with some data outright, and it's going to reference the exact icon that's below us. So the way that we can do this is, let's just call this icon, and it is a sprite2D type, and we know what type it is because if we click on it and we check over here, this is the name of the type. Okay. Now we're going to assign icon to $icon. Okay. So if you had more nodes and stuff like that, it would actually be something like icon, my node, something else, right? That's how you would reference something deeper. But in the case here, we're only just referencing the icon, and we only want to call it once. It's very performant to do it this way. You shouldn't have to do multiple $signs. You should be storing them and storing their value pretty much once. Now that we've done that, we know that there is a function called invoke from parent that exists on an icon. So we can literally just do invoke from parent like this. You're not going to get auto completion, just to be clear. There is no auto completion for something like this. I've tried to get it to work, but it seems to be kind of buggy and just doesn't always work. But if I go ahead and hit play, we are invoking that function from the parent. So it's going down. So this script is referencing this node, going into this node and calling this function. Okay? So now let's talk about how to do this in the opposite way, right? And that is with something called signals. So if we go to signal, we do invoke, or let's call it send to parent. Okay? And maybe we want to pass a message up like this. Okay, so it kind of looks similar to a function, but we're just defining the signal. So when we invoke from the parent, what we're going to do is send this information back up to the parent. We're going to do send to parent. We're going to call it emit. We're going to say hello world. Okay, and then inside of the parent itself, what we need to do is listen for that event happening. So we can do icon connect, and we can listen for hold on, it's called, I've actually done this, emit hello world, send a parent. Yeah, that's right. So we do icon connect, and it should just be send a parent. Then we can call a function result, right? So let's call a new function that's called result. So it's essentially like a callback, right? Put a callback in here and it calls that function when it's ready to go. Okay, so let's go ahead and print that message out up here, like this, and then we could do print this was sent up from the child node. Okay, refresh, there it is. This was sent up from the child node, hello world. All right, so we've now gone through a full loop. So let's talk about exactly what just happened so you can kind of understand. In the very top parent class, we are getting a reference to the icon. We are storing that reference. We are then taking the stored reference. We are connecting a function. So when a event called send to parent is emitted, it is calling the result function here. And then after that, we are invoking a function directly inside of the script that is attached to icon, which is called invoke from parent. So if I click on this, we'll see the function invoke from parent, which is called. It is using the signal that is defined here to send that information back up to the parent. And then from here, it goes through results, and then we print all that data out, right? Pretty cool stuff. Like, signals are really, really excellent for passing data all the way to the top in a non-complex way. And you can do it entirely through code, which is excellent. But hopefully that kind of helps you understand what signals are and why they're very useful. All right, now that we've actually talked about signals, there's one other function type I wanted to talk about because this is where it's most relevant. Sometimes you don't want an extra function like this and you want to do something that's more inline, or pretty much just do essentially what would be like a fat arrow function inside of JavaScript or TypeScript. So what we can do is actually just define a function like this, and as long as our indentation here is the same, we can actually just add as much code as we want into this, basically what's a callback function. So if I just do print message here, we're going to get rid of some of the other results that we're seeing below. And if I hit Control S and run the function, we'll see here that we got the message, which is just hello world. Now it's really nice because this is like really simple, and you could even essentially make this a one-liner if you wanted to, like this, which is really great as well. So if I refresh, we'll get the same result. And yeah, it's nice. I mean, this is how you would pretty much just declare essentially what is just a function for a one-shot thing like this, directly like that. And one of the last things that I actually wanted to talk about is exports. Well, not the exports that you're familiar with. See, in Godot, what we can actually do is, instead of doing this direct reference like this, we could actually use something called an export, where we can directly define which thing is attached to which thing. So maybe my icon is in a really, really deep place, So let's say it's something like, let's go ahead and give you an example here. Let's say it's in something like where we have a node here, like this. Let's just say it's this many deep, right? And if I want to access this node, I'm going to need to do this. And that's not exactly the greatest way to access a node, right? So I'm going to show you how to actually do this in a completely different way. So if I add export on here and I remove this, what I can do is I can click on the main script, and over here we're going to see a way to assign what it's looking for. In the case here, we're looking for a sprite 2D, right? So if I click on this, and OK, it is now assigned. The function will still do the exact same thing, and we'll get the exact perfect reference to what we're looking for. So exports are incredibly useful for not just assigning specific nodes that we want, but also for customization of individual scenes as well. Like maybe I don't want this message to be hello world. Instead, maybe I want it to be something that I define. So what we're going to do is redefine this export here. And if we click on this node, go to 2D, over here on the right, we'll see my message, right? I can say hello from text box. Okay, and if I hit save scene, and I hit play, we'll see hello from text box down here. Now that's pretty cool because you can do a lot of customizable exports just based on this. So keep that in mind, that this is another option for you if you have really deep nodes, a lot of tree structure, and so on and so forth. It's a little bit easier for when you're assigning nodes that are going to be moved around and stuff to just directly reference that node. So that being said, I hope that's enough for kind of covering everything that has to do with Godot Script for a TypeScript or JavaScript developer. It's got a lot of similarities, but there's like little tiny details that you don't exactly catch on until you start working with the language. But I'm hoping it can ease the pain to go from a TypeScript and a JavaScript environment over to a game development engine like Godot, where you're using GD script and all that sort of stuff. So anyway, hope you enjoyed it. Let me know if this was useful for you.